so we're starting lesson 2-3. Like I said, we're going to spend a few days on this because there's a whole lot of information in this lesson. And eventually what we're going to construct at the end of our 3 days is something called the unit circle. Have you ever heard of that term? Someone else maybe who took this class talked about the unit circle. Okay, so we'll start out pretty basic. An angle consists of two blank with a common blank, which is called the vertex of the angle. What do you think I'm looking for in those blanks?
Two sides.
Okay, two sides. If I have a common blank, what would that be? Vertex, which is called the vertex, but it is the, look at this picture over here. Right there, what are those two things? Not lines, rays, yes. So two rays with a common end point, which is called the vertex of the angle. Okay, so there's our vertex. And of course, lines and not rays can create angles as well. Okay, so label the axes and the quadrants. Where is the x-axis? Which one?
The one going.
What do we call that? Someone said it.
Horizontal.
Horizontal. X-axis. And the y-axis is the vertical one. Where is quadrant 1?
The one up to the top left.
Top left? That would seem logical, because that's where we start reading.
No, top right.
Yes, it's over here, and there actually is a reason for it that we'll get to in just a second. So this is quadrant 1. Sometimes we use Roman numerals for it, or you could just use a regular number. 2 goes this way. 3. And 4. Okay, so why are they numbered that way? We're about to see. In trigonometry, an angle is in standard position if one ray, which we call the initial side, we're going to use that term a lot, standard position, if one ray, the initial side, is on the positive x-axis, and the other ray, the terminal side, rotates to form an angle with the vertex at the origin. What? Okay, so looking at this picture here, I have a ray sitting right there. Okay, that would be considered the initial side of my angle. And then I take this other ray and I rotate it, and wherever it stops rotating, then I call that the terminal side of the angle. And then this angle right here is whatever amount I rotated. So that amount that I rotated is between 90 degrees and 180 degrees, right? Because it put me in that second quadrant. Okay, so a positive angle indicates counterclockwise rotation. What is counterclockwise? And if you forget, look at how the clock is rotating, and it is the opposite. Yeah, counterclockwise goes this way. So counterclockwise is that. And we call that a positive angle. Now, I know a protractor doesn't have a negative angle measurement on it, so we just use negative angles to indicate which direction we rotated. So the negative tells me which way to rotate. It's not actually the negative, that the angle itself is negative. Okay, so if I rotate clockwise, just like the hands on the clock, then that's considered a negative angle. So the way that this arrow was drawn here, that would be a positive angle rotation, somewhere between 90 and 180. So that's why this is called quadrant 1. It's the first quadrant we rotate through on a positive rotation. So we start on the positive x-axis, and we rotate through this quadrant first, and then we rotate through that one second, third, and fourth. Okay? All right, so we're going to sketch the following angles using arrows to indicate the direction of our rotation. So the first one is 270 degrees. So we always start on the positive x-axis. And then we take another ray and we rotate this amount. Now, if it's a positive angle, which this is, that tells me to go counterclockwise. So if I start there and go counterclockwise 270, where do I stop rotating? Start here, and I rotate counterclockwise
You stop
270
on the y-axis.
down here. Okay, and that's pretty easy to figure out because each quadrant's 90, so 90, 180, 270. So I would stop rotating here, and my direction of rotation was that way. So that tells me which way I went, where I started, where I stopped. And often we'll just draw in the arrow or the ray where we stop because it's always known that you start on the positive x-axis. Okay, so let's look at pi over 3. What's the fraction that we use to convert? Okay, and we use that because 180 degrees is equated to pi radians, correct? Okay, did I show y'all the quick mental way of converting some of these? Okay, yes, so you know that pi is the same as 180, so 180 divided by 3 is 60. So that is the same as 60 degrees. So if I rotate a positive 60 degrees, which quadrant do I stop in? We always start here, and a positive angle tells me to go counterclockwise. So if I go counterclockwise 60, which quadrant am I in? The first, yes. So I'm going to draw this, and I'm just going to do this for my 60, or pi over 3. So I'm just doing that terminal side because I know where the initial side is. Terminal side's the only thing that's going to change there. Okay, so now let's look at some negative ones. What about negative 400 degrees? Okay, well that's more than one time around, isn't it? Because 360 is a full circle. So that means that I'm going to go, John, which direction? Clockwise or counterclockwise? Clockwise because it's negative. So I'm going to go all the way around. And then how many more degrees? 40. And you did that by what? So this is negative 400 degrees. Puts me in the fourth quadrant because I had to go a little bit more than 360. Question on that? Okay, what about negative pi? How much is pi? 180. So what if I go clockwise 180? Where do I stop? Over here. What if I went positive pi? Same place. Yeah. Okay, so negative pi tells me to go clockwise. Pi radians, which is the same as 180. So if I went clockwise 180, I am over here. Like that. Any questions on those? Alrighty, next page. Okay, so one of them previously that we did was one of these. A quadrantal angle has its terminal side on an axis, not in a quadrant. That's kind of misleading, isn't it? Because what's the root word in quadrantal? Quadrant. But a quadrantal angle isn't in a quadrant. It's the exact opposite. It's on an axis. So which one over here did we do that stopped rotating on an axis? Okay, yeah, there were two. Negative pi and 270. All right, so let's list those as two examples there. So negative pi, and didn't we also say that pi would get to the same place? Or you could call it negative 180, positive 180. Okay, 270 is what we did in the first one. Give me something else. 360. Give me an angle that would land on the upper y-axis. 90 works? Okay, so I think that's enough. All right, so all those are quadrantal. A coterminal angle shares a terminal side with another angle, and they stop rotating in the same location as each other. So we kind of touched on that already with the pi and negative pi, or 180 and negative 180. They will go to the same location. Okay, so let's list those as our first example. I'll say negative 180 and 180. Pi and negative pi. Okay, what about give me something, let's take 90 degrees. Find me something else that would be coterminal. Stop in the same place. Negative 270, yep. Just need an image up here. Okay, so 90 is right here, but also if I went clockwise 270, I would get there. So negative 270 is a good one. What about 50? Negative 310, and how are you getting that? Okay. Give me another one. If I rotate 50, I'm right here in the first quadrant. But how could I rotate more and still end up right here? And how do we get that? Yeah, add another rotation. So if I want to stop at the same location, all I need to do is add another rotation, and then I'm right back where I started. So I need to add 360. So if I add 360 to 50, that gives me the 410. If I subtract 360, that gets me the negative 310. So you're really just adding a rotation in either direction, which means add 360 or subtract 360. How many of these could I find? An infinite number. Yeah, there's not just one right answer. I could keep adding 360 or I could keep subtracting 360. Okay, so those are coterminal. All right, next one, we're going to take the angle that I'm giving you, we're going to sketch it, figure out where it would be, and then we're going to find a positive and a negative coterminal. Okay, so 30 degrees would be somewhere in here, rotating in a counterclockwise direction because it's a positive angle. Okay, so give me, you can probably do this mentally, give me a positive coterminal angle with that one. 360 plus 30 would be 390. So I'm just adding one more circulation, which is 360 more degrees. Okay, but to find a negative, then I would just go one circulation clockwise, which is negative 360. So what is 30 plus negative 360 or minus 360? Negative 330. So there's a negative and there's a positive coterminal. Those aren't the only right answers. You could add it 2 or 3 times, subtract it 2 or 3 times, or however many times float your boat, you'd still have a coterminal. Okay, negative 150. Okay, just everybody give it a little bit of thought. If I go clockwise 150, which quadrant am I in? Don't give me an answer yet. Let everybody kind of process it. Clockwise 150 puts you in which quadrant? I didn't understand him anyway, did I? Does everybody have an answer? Haley Beth, what are you thinking? Third? John, is that what you said? Y'all agree? I agree with her. Clockwise 150. So I know I have to go past 90, but not quite to 180. So it would definitely be in the third quadrant. Nice job. Now, take your calculator or your brain and find a positive and a negative coterminal for me. All right, someone give me their negative answer. Negative 510. Someone give me their positive answer. 210. Do we agree? So you're adding 360, that gives us 210. Subtracting 360, that gives us negative 510. Question? What am I going to do with 2 pi over 3? And I'm going to say we're not going to convert. We're going to leave it in radians. Okay, so how much is 360 in radians? 2 pi. Remember, 1 pi is 180, so 2 pi is 360. Okay, so I'm going to say 2 pi over 3 plus 2 pi. Well, that's 2 pi over 1. I need common denominators. What does my denominator need to be? 3. So I'm going to multiply this fraction by 3 over 3. I'm multiplying it by 1. I'm not changing the value of it. Okay, so that's 2 pi over 3 plus 6 pi over 3. And then I can finally add them up, and I get 8 pi over 3. Easy enough? Well, very good. That's exactly what your face was telling me. What? Okay, so I added 2 pi, which is equivalent to 360. But I can't add those because I don't have like denominators. So I had to get common denominators of 3. So this whole product here became 6 pi over 3. Then once I have common denominators, I can combine like terms in the numerator. And that's where I got 8 pi over 3. Who else has a question on that one? Yes.
So since 2 pi equals 360, can you just divide 360 by 3 and then get 120 and just plot that?
Yes, if we were converting. But remember I said I don't want to convert on this one. Just because I wanted you to use your brain. Your brain is capable of great things. Okay, so let's do 2 pi over 3 minus 2 pi. Okay, so that's 2 pi over 1. That's 2 pi over 3 minus 6 pi over 3. And I know where I got that because I did that little common denominator thing above, so I'm just borrowing that number that I got. And now I can subtract my like terms. 2 pi minus 6 pi is negative 4 pi over 3. Just fractions. Questions? All right. How many of you have taken the SAT yet? Only one. Wow. ACT? Oh, we got to chop, get on it, guys. Do y'all know that there's a portion of both of those tests where you can't use your calculator? Kaylee, Isabel, Tyler.
Oh, yeah.
Are you senior, John? I keep wanting to make you a junior. Okay, yeah, so quite a few of you. Oh, we got to get y'all testing it. If you're planning on going to 4-year school, that's what we need to be doing. But yeah, there's a portion of that test where you can't use your calculator. So when I'm like, don't touch your calculator, there's a reason for it. Well, 2 reasons. One, you need to know that for test prep. But also just let your brain do some work. It feels good sometimes to do it by hand. All right. No. Your brain is capable of really hard things. But you got to use, it's a muscle, right? Isn't it a muscle? Isn't that what they say? Seems kind of weird, but you got to use it. You got to exercise it. Okay, so here we go. Here's a circle at the bottom of our paper. From geometry, this is the equation of a circle centered at the origin. X squared plus y squared equals r squared. And you can kind of see where this equation comes from. If we look at this triangle that I have inscribed in this circle here, theta is the angle up here by the origin, and this ordered pair right here is some generic ordered pair xy on the circle. If I drop down from this point such that it's perpendicular, and I connect that radius there to that point, then I have a right triangle. X squared plus y squared equals r squared is where the equation comes from. Okay? All right. using this triangle. Did I rotate a positive or negative angle? All indications are positive because I don't have a little arrow indicating that way. Okay, so we rotated some angle theta. Puts us in the first quadrant. If this ordered pair is xy, why is this side x and why is this side y? Yeah, you think if you plot an xy ordered pair, don't you go right x and up y? Okay, so that's why the lengths of the sides are labeled x and y. And this is r because it's a radius of the circle. So that's why the x, y, and r are being used. Okay, so we're going to use this triangle here and set up all 6 trig ratios of theta. Okay, now I don't have numbers, I just have variables here. What is sine? Opposite over hypotenuse. What is opposite theta? What is the hypotenuse? R. Okay, well let's go ahead and do its reciprocal. If sine is y over r, what is cosecant? R over y. Okay, looking at that triangle, cosine is adjacent over hypotenuse. What's adjacent to theta? X. What's the hypotenuse? R. Secant is the reciprocal, so the reciprocal will be r over x. Tangent is opposite over adjacent. What's opposite theta? And what's adjacent? And cotangent's the reciprocal, so that will be x over y. Okay, in a little bit, we're going to put that on our formula sheet as well. All right, so this is really cool, y'all. Remember someone said, why can't we use the 90 degrees? Using the previous ratios, trig functions of any angle, acute, right, or obtuse, with given point xy on the terminal side can be found using these formulas. So, this tells me that I can use this as a rule or a formula, and no matter where my ordered pair is, I can find those 6 trig ratios. So in geometry, you only stuck with acute angles. I can find sine of 180. I can find sine of 270. I can find tangent of 360. Or any angle that you ask me. Using this as our rule. Okay? All right, so not only is that going to open up a whole another door with opportunities, but sometimes they're going to be negative. If I have an ordered pair in the second, third, or fourth quadrant, part of that ordered pair or all of that ordered pair is going to be negative. So sometimes we'll get negative values now. Very cool, very cool. Okay, next one. Point P, which is 0, -8, is on the terminal side of angle theta. Use x, y, and r to find all 6 trig ratios of theta. Draw a picture. You're going to get sick of me saying draw a picture. All right, draw a graph. Doesn't have to be terribly large. And plot the point 0, -8. Okay, imagine that there is a circle maybe a little more circular than I drew, but there is a circle containing that point. Okay, x is 0 and y is -8. And I know that just strictly from the ordered pair. But what is r in that circle? 8. A radius of a circle is always positive. Okay, so I have x, y, and r, and we're going to flip back over and use these as our formula to figure out what sine, cosine, tangent, all these great things are. Okay, so here we go. Sine of theta. Okay, I don't need to find theta. I mean, if you wanted to, you could say, well, clearly theta is 270. Or clearly theta is negative 90. It doesn't matter what the angle is. I know x, y, and r, so I can just plug them into that formula. Okay, so y over, let me write out y over r while you're getting used to what these are. Y over r. Okay, the y is negative 8 and the r is 8. Because I'm imagining a circle through that point, and what would your radius be? That distance, which is just 8. Okay, so sine is just negative 1. Okay, so that seems weird, doesn't it? We've never got negative answers. But let's say I called this 270. If I rotate 270, I'd be in that location, right? Let's see what sine of 270 tells me. Sine 270, negative 1. Okay, very cool. All right, so what's cosecant? What's the reciprocal of negative 1? Negative 1. I mean, imagine if I flip that fraction right there, I'd still get negative 1, right? Okay, cosine. Cosine is x over r. Look back on the previous page. My x is 0, r is 8. What is 0 divided by 8? 0. But the reciprocal secant is r over x. Well, r is 8 and x is 0. What is that equal to? Undefined. Remember, we can't divide by 0. There's no number that I can put there that I can multiply by 0 and get 8. Remember talking about that? Okay, tangent of this angle is y over x. The y coordinate was negative 8. X is 0. What's that? Another undefined. And let's just see what the calculator says if I want tangent of 270. Tangent 270, domain error. That's its way of telling me it's undefined. Because it's saying, oh, there's a domain problem. I can't divide by 0. Okay, cotangent is the reciprocal x over y. X is 0, y is negative 8. 0 divided by anything is 0. So we can find all 6 trig functions of any angle at all. It does not have to be acute anymore. All right, before I do this next one, I want you to go ahead and get your formula sheet out and let's add this to it. Okay, so sine y over r, cosecant r over y, cosine x over r, secant r over x, tangent y over x, and cotangent x over y. Make sure you're copying it correctly from your notes or from up there. That's the only thing we're adding. So once you get that, you can put that back in your sheet protector. But keep it out on your desk because we'll be using it. have it written down. All right, so now let's go to the next example. Let's see where I want to get to today. Okay, I think we'll go through example 5 and then we'll stop there for the day. Okay, example 3. Let theta be the acute angle in standard position whose terminal side contains the point 5,3. Find the 6 trig functions of theta. Draw a picture. Okay, that's a whole lot of new words in there. Okay, so we know theta means an angle. An acute angle, less than 90, in standard position. That means I started rotating on the x-axis and then I went counterclockwise. Whose terminal side, that means where I stopped rotating, is the 0.53. Actually, I don't know if I went counterclockwise or not. It doesn't matter because it's telling me I'm stopping in the first quadrant. So it could have gone there clockwise. Find the 6 trig functions of theta. Okay, so let's draw a picture of what's going on. Which quadrant is this ordered pair in? 1. I'm going to focus my drawing on quadrant 1. I don't really need all 4 quadrants if the point's in the first quadrant. Okay, so I'm going to go over 1, 2, 3, 4, 5, and up 1, 2, 3, and my point is here. It says the terminal side contains that point. That means that I rotated some amount and the ray stopped so that it went through that point. So maybe I rotated here, maybe I rotated around here, but it's telling me theta is the acute angle. So that means that it is this angle, as opposed to the one outside that, almost 360 degrees. Okay, so acute angle is theta. Standard position means I started rotating here, I stopped rotating there. That terminal side went through the 0.53. Now, I am going to draw a right triangle from that. Okay, y'all listen to me. Every single time the perpendicular is with the x-axis. Every single time perpendicular goes to the x-axis. Every single time theta is over there by the origin. Okay, where you're rotating. Okay, so I've made a right triangle. If this ordered pair is 5, 3, what's the length of this side? 5, because I went right 5 to get to that point. What's the height of this leg over here? 3, because I went up 3 to get to that ordered pair. Okay, to find all these 6 trig functions, I need x, y, and r. I know x and y. X is 5, y is 3. But how do I find r? Pythagorean theorem. And if we get a radical, we're going to leave it as a radical. Okay, and it's easier to deal with than a decimal. Okay, so we're going to say 5 squared plus 3 squared equals, I'm going to call it r squared. If you use c squared, that's perfectly fine too. 25 plus 9 is r squared. 34 is r squared. So what is r? Square root of 34. It doesn't simplify, so we're just going to leave it like that. Now, the radius of a circle is really what this r represents. And a circle's radius is always positive. So I'm going to put a note here. R is always positive. No matter which quadrant we're in, or which axis we're on, R will always be positive. I'm going to write a note here as well. Theta is always near origin. So I would not put theta up here at the top of the triangle. It's always going to be over there by the origin. And this perpendicular, the right angle, is always on x-axis. R is always positive. The right angle goes to the x-axis, and theta is up near the origin. Okay, so we found R with square root of 34. Now that you have x, y, and r, we use those formulas that I put on the board, that you put on your formula sheet, that are in your notes, and we'll just fill them all in. Okay, so we're going to have, I didn't leave myself much room. Sine of theta is y over r, 3 over square root 34. If I rationalize that, square root 34 over square root 34, what does that give me? 3 over 34. That is the sine of that angle. Okay, let's go ahead and do cosecant. Okay, it's the reciprocal of sine. I don't want to take the reciprocal of this fraction because then I have to re-rationalize. I'm going to take the reciprocal of the first one I wrote. So I'm going to put the r over y, and then my work is done. Okay, cosine is x over r, 5 over square root 34. If I rationalize that, what do I get?
5 square root 34.
Okay. Secant is that reciprocal. So I'm going to go back here, take that reciprocal, r over x. And then tangent is y over x, 3 over 5. Cotangent is x over y. Question. All right. We're going to do 2 more that are basically just like those, but in different locations. And then we'll stop with the notes today. Okay, example 4. Point P is negative 5, 3. It is on the terminal side of angle theta. Use x, y, and r to find all 6 trig ratios of theta. Draw a picture. Which quadrant are we in? Second. So I'm going to just focus my drawing on the second quadrant. I'm going left 5, up 3. I have a point. This angle rotated and went through that point. Not very straight, but that's all right. Went through that point. Okay, I'm going to form a right triangle. Where does the perpendicular go? Down to the x-axis every single time. With the x-axis, that's where your 90 degrees is. Theta is always by the origin. And those rules are just established so that we all come up with the same exact situation here. Okay, what is R? How do I find it? Pythagorean theorem. You find R, I'll find R. No surprise that I got the same thing. So we're basically using the same numbers, right? Okay, so I'm going to label that R there. X equals negative 5, Y equals 3, R equals square root 34. If I'm labeling this triangle, Yeah, watch what I'm going to do. This is using a negative as a direction again. I'm going to label this side as -5 and this one is +3. Because I went left 5 and up 3. So again, negative is indicating direction there. Not a negative length, but a negative direction. Moving left. Okay, so here we go. Let's plug them all in. Sine of theta is y over r, which is 3 over square root 34. Rationalizes 2. Okay, are y'all good with that? Only 1 or 2 of you are answering me. Are we good with that? Okay, can you do it in your head? Okay, if you can, it saves you time. Okay, cosecant is r over y, which is square root 34 over 3. Cosine is x over r. Try to get these memorized. It'll just make your work faster. X is -5. R is square root 34. And that becomes -5 square root 34 over 34 if I rationalize it. Secant is r over x. R is square root 34. X is -5. Now, y'all, is it wrong to leave a negative in the bottom? No, I don't like it because sometimes I miss it if it's in the bottom. So I will generally either bring it out front or in front of the numerator. It's just easier to see if it's up there, but it can stay in the denominator if you want it to. Tangent is y over x, 3 over -5, or -3/5. And cotangent is x over y, -5 over 3. Questions? Okay, so what about opposite, hypotenuse, adjacent? Like, are we ditching those? Not at all. Isn't opposite the same as y value here? Isn't the adjacent the same as the x value? And isn't the radius the same as the hypotenuse? So we're still using opposite over hypotenuse, adjacent over hypotenuse. But sometimes these values will be negative to indicate a different direction. Okay, last one of the day. Point -1, -1 is on the terminal side of theta. Same directions. Which quadrant? 3. -x, -y. So I went left 1, I went down 1, I have this ordered pair, I rotated some angle that is clearly more than 180 or more than 90, even if I went that way, but I'm going to make a right triangle with the x-axis. My acute angle theta will always be up there by the origin. Now, labeling these sides. This ordered pair is -1, -1. So if I want to think of these sides, I will use a negative for both of them, indicating that we went left and down. Just indicating direction. Find the hypotenuse for me. Square root of 2. Do these numbers look familiar to you? Wouldn't this be a 45, 45, 90? The legs are the same. Got square root of 2 on the hypotenuse. Okay. All right, so I have x equals -1, y equals -1, r equals square root of 2. Okay, I want you to find all 6, and we'll call it a day. And I do have your homework to give you. It will be due Tuesday, not Monday, after we finish up all these notes. I'm going to do mine up here, and then we'll compare. check up here when you finish. And I'll bring around the homework. You may start on it now if you want to get a jump on some of it. But again, it will be due on Tuesday.